Question 1. So to add mixed numbers, we've got to start off by making them improper fractions, top-heavy fractions. So 2 1/7 is 15 sevenths, and 1 1/4 is 5/4. Now, to add fractions, we need to have a common denominator, and 7 and 4 both go into 28. So let's make 28 our common denominator. So we need to find the equivalent fraction for 15/7. Well, we've multiplied the 7 by 4 to get 28, so we multiply the 15 by 4 as well to get 60. And then moving over to the 5/4, we're multiplying top and bottom by 7 to get the 35/28. Now that we've got the common denominator, we can just add the numerators. 60 add 35 is 95, and 95/28 would have given you full marks, but turning it back into a mixed number, we get 3 and 11/28. Now for part B, for this division, to start with, we again have to turn the fractions into improper fractions, so the 1 1/5 becomes 6/5. Now when we divide fractions, the process is to change the sign from a division to a multiplication, but remember to flip the second fraction over. So 3/4 becomes 4/3. So it's now a straightforward multiplication where we do top times top, bottom times bottom. 6 4s are 24, 5 3s are 15. 24/15 simplifies to 8/5 when we divide top and bottom by 3. And turning that into a mixed number, we get 1 3/5. Question 2. The number of houses and the number of flats are in the ratio 7:4. So houses to flats, 7:4, and flats to bungalows are 8:5. Now we've got the flats having a ratio of 4 for the first fact and 8 for the second fact. Now we really want this share, the flat share, to be the same. So if we choose to take our 7/4 ratio and multiply both by 2, we get 14:8, and now we've got the flat ratio of 8 in both the ratios. So it's 14:8 houses to flats and 8:5 flats to bungalows. So overall that's 14:8:5. 14:8:5. Now we're told there are 50 bungalows, so we can see the actual numbers are 10 times more than our ratio. So how many houses have we got? Well, 14 times 10 gives us 140. Question 3. So Rennie buys 5 kilograms of sweets. Well, 5 kilograms is 5,000 grams multiplied by 1,000. Now each of the bags that we're putting the sweets into, we're putting 250 grams worth of sweets. So we've got 5,000 grams of sweets into bags, 250 each. So that gives us 20 bags worth of sweets. That's 5,000 divided by 250. Now each of these 20 bags was selling for 65p each, so that's 1,300 pennies, which is £13. So our profit, well, we're selling them for £13, we bought them for £10, so our profit is £3, but we're being asked for our percentage profit. So our percentage profit is the profit divided by the original cost multiplied by 100 to turn it into a percent. So 3 divided by 10 times 100 is 30%. Question 4. So note that this is an estimating question, so we're not just using the actual figures, we're estimating. So the race across America is 3,069.25 miles, so this is approximately 3,000 miles. And his average speed is 15.12 miles per hour, so that's roughly 15 miles per hour. So how many miles are we going to do in a day? Well, we're cycling at about 15 miles per hour, 8 hours a day. 15 times 8, so we're going to do about 120 miles per day. So 3,000 miles in total, and we're doing 120 miles per day. So we want to do 3,000 divided by 120. Well, I've divided by 10, then I've halved it and divided by 3. That gives me 25 miles as an estimate. Now for part B, we're now told the average speed is actually increasing to 16.27 miles per hour. Now they allowed two completely different answers here. You could either have said, well, it's going to take less days because obviously you're travelling that bit faster, so that would have been absolutely fine. You could just say less days required. Or alternatively, you could have said, well, 16.27 miles per hour, I would still have rounded down to an estimate of 15 miles per hour, so my calculation would have remained unchanged. So either of those two answers were fine for part B. Question 5. We're being asked in part A to draw an accurate front elevation, so the view we would see from the front. So from the front we would see a base of 6 and the height that we would see would be 4. So we just need to draw an isosceles triangle with a base of 6 and a height of 4. Now to work out the total surface area of the pyramid, just imagine you're covering the pyramid in wrapping paper. So we've got 4 triangles which are the same, which have got a base of 6 and this perpendicular height of 5. So each of these triangles is going to have an area of half times base times height, so half times 6 times 5, which is 15. 4 of those triangles, so that so far is a surface area of 60. Then of course we've got the square on the bottom with sides of 6, so the area of that square is 6 6 is 36, so that's a total of 96, and make sure you include the centimetres squared. Question 6. So I'm going to focus on the x-coordinate of C first of all. So we can see in terms of the x-coordinates we're going from 6 here to 38 here, and that is a length of 32. Now that comprises the base of 4 of the squares. So 32 is the length of 4 of the squares, so each of the squares must have a side length of 8. So all of these squares have got a side length of 8. So with regard to the x-coordinate of C, we can see that we're 2 squares worth along from A, so the x-coordinate is going to be 6 plus 8 plus 8, which is 22. Now for the y-coordinate, I'm actually going to look at it from the point of view of counting down from B. So we're presently at a y-coordinate of 36 here. Take away 8, take away another 8, and that takes us to the y-coordinate of C. So 36, which is here, take away 8, take away another 8, gives us 20. So the overall coordinate of C is 22, 20. Question 7. So we start off by reflecting shape T in the line x equals -1. So remember that's this vertical line down through -1. So reflecting this across we come to here, and this is shape R. Now we've now got to reflect this in the line y equals -2, which is this horizontal line. That takes us to the shape here. So this is where we end up. Now how could we describe the single transformation that will map T onto S? Well, you can do it by way of a negative enlargement, but I think it's much simpler just to think of this as being a rotation by 180 degrees, and the point that you're rotating around is going to be where these two reflection lines cross. So that's about the point of -1, -2. So whenever you have one of these double reflections, it's always going to be a rotation by 180 degrees about the point where the two mirror lines cross. Question 8. So I've started off just by doing a little right angled triangle with the sides 3 and 4 and 5 to help me gather my thoughts. So the perimeter of this little triangle, given it had the sides of the ratio, would be 3 plus 4 plus 5, which is 12. Now I'm told that actually my triangle has got a perimeter of 72. Well, 72 is 6 times as big as 12, 6 12s being 72. So all my lengths of my triangle are going to be 6 times bigger than my initial purple triangle. So multiplying each of these by 6, I get lengths of 18, 24, and the hypotenuse being 30. Now to work out the area of this triangle, well, of course it's just half times base times height. So half times 18 times 24, half of 18 is 9, so 9 times 24, which is 216 centimetres squared. Question 9. 36 to the power of a half just means the square root of 36, which is 6. Anything to the power of 0 is 1, so part B is 1. Now for part C, because we've got the negative involved in the indice, remember this means we've just got to flip it over. So I like to think of it as starting off getting ready to flip. So we need a fraction to flip over. So think of 27 as being 27 over 1. So that's our starting position. 27 over 1 to the power of minus 2/3. So first of all, deal with the minors. So we just flip the fraction over. So at that point we've got to 1 over 27 to the power of 2/3. Now the denominator is making it smaller, that's cube rooting it, while the numerator is making it bigger, that's squaring it. Now you could square than cube root, but that's difficult with 27, so you're much better off doing it the other way around, choosing to cube root first and then square. So I'm going to cube root the 1 and cube root the 27, giving me 1 over 3. Now these still need to be squared. 1 times 1 is 1 and 3 3s are 9. So our final answer is a ninth. Question 10. So with this, it's pretty straightforward. You just need to know what a box plot looks like. So it starts off with the least height, which is 133. Now the rectangle commences at the lower quartile of 145. The line inside the rectangle is the median, so that's at 151. And the line at the end of the rectangle is the upper quartile, which is 157. And then the very final line on our box plot is the greatest height, which is the 170. So there we go, that's how we got all these points. The height of the box plot doesn't matter, that's just up to you. Now for part B, work out an estimate for the number of these girls with the height between 133 and 157. So that's all the way from the start, all the way up to the upper quartile. Now that's going to comprise 3/4 of all the girls, because we've got a quarter going up to where we start. So a quarter up to the lower quartile, a further quartile up to the median, then another quartile up to the upper quartile. So that's 3/4 worth of the girls. 3/4 of 80. 80 divided by 4 is 20. 20 times 3 is 60. Question 11. So we're told that angle ABO is x degrees. Now our starting point is to appreciate that the triangle AOB is an isosceles triangle, because both AO and OB are radiuses of the circle. So because this is an isosceles triangle and we've called this angle here x, then angle AOB, AOB, yeah, that's what I said. AOB is also x, because base angles of an isosceles triangle are equal. Now once we know that, then this angle here, angle AOB, must be 180 degrees take away 2x, our x and our x, because angles in a triangle add up to 180 degrees. Now if that angle there in red is 180 minus 2x, then this angle here in pink, angle BOC, must be 180 take away the red angle, because angles on a straight line total 180. So 180 take away 180 minus 2x is 2x. So this angle here is 2x. Now we know this angle here is a right angle, because the angle between a tangent and the radius is 90 degrees. It's perpendicular. The radius is perpendicular to the tangent. So given this is 90, given this is 2x, this angle here, the angle we need to work out, angle ACB, must be 90 minus 2x, because we've got 180, take away our 90, take away this 2x, leaving us with 90 minus 2x. And that final reason that we must give is because obviously angles in a triangle total 180 degrees. So five angles we've worked out, 5 facts we should give for full marks. Question 12. Well, our starting point with any of these proofs we have to do with even and odd numbers is to say that 2n is always going to be an even number, because you double anything, it's going to be even. So if we then add 1 onto that, then it must be odd. So given we're dealing with odd numbers, we're going to be kicking off with the fact that 2n plus 1 is odd. Now we've got to prove that when we square this, it is always 1 more than a multiple of 4. So let's go and square it. So our odd number is 2n plus 1. Let's go and square this. So it's 2n plus 1 times 2n plus 1, which gives us 4n squared plus 4n plus 1. Now bearing in mind that what we're aiming for, it makes sense now just to factorise the first 2 terms. So we've got 4 lots of something, and then we're adding the 1 at the end. So given that we're always multiplying by 4 and then adding 1, we can say that that's always going to be the case. So 4 lots of n squared plus n plus 1, so we're always going to be 1 more than a multiple of 4. So that's what we needed to get to, because we can see that we're 1 more than a multiple of 4. Question 13. So kick off by multiplying off at the bracket. So root 5 times root 8 is root 40, and root 5 times root 18 is root 90. Now we're trying to have a root 10 wherever we can, so let's simplify root 40 to being root 4 times root 10, and simplify root 90 to being root 9 times root 10. Now the square root of 4 is 2, so this is 2 lots of root 10, and the square root of 9 is 3, so this is 3 lots of root 10. So 2 lots of root 10 plus 3 lots of root 10 is 5 lots of root 10. So our a, the coefficient in front of the root 10, is 5. Question 14. So let's start off with this first fact, that y is inversely proportional to d squared. So y equals k over d squared. I've just called it k1 because we're going to be having another constant a bit later. So y equals k over d squared. Now we're told that when d is 10, y is 4. So substituting this in, we can say 4 equals our unknown constant over 10 squared. So 10 squared is 100, multiplying both sides by 100, we can see that k must be 400. So our revised formula, now that we know the constant is 400, is y equals 400 over d squared. So let's just park that for now. Now looking at the second fact, we're told that d is directly proportional to x squared. So d equals k x squared. I've just called it k2 as I said earlier on because it's a different constant to over here. So d equals k x squared. Now we're told that when x is 2, d is 24. So 24 equals k times 2 squared. Well, 2 squared is 4. Dividing both sides by 4, we get k being 6. So d equals 6x squared. We've worked out that the constant k is 6, so d equals 6x squared. So we've got 2 facts. We know y equals 400 over d squared, but d equals 6x squared. So let's go and substitute this 6x squared being d into here. So y is going to equal 400 over d, which is 6x squared, all squared. So y equals 400 over 6x squared, all squared. So looking at the denominator, 6x squared times 6x squared is 36x to the power of 4. Then simplifying the fraction, we can divide top and bottom by 4, giving us y equaling 100 over 9x to the power of 4. Question 15. So this is one of these difference between two squares. You've really just got to have seen it before and know how it works. So this equals a plus b times a minus b. And once you know it, you can see it, because a times a would be the a squared. A times minus b is minus ab. But b times a is a plus ab. So those two middle terms will cancel out. And then the final clause will give us our minus b squared. Now for part B, we very much do need to follow up the hence. It's much simpler if we just appreciate that this is just a version of part A. So our first term being squared, our A if you like, our A being squared, our A is x squared plus 4, and then we're taking away something being squared, so our B is x squared minus 2. So our A is x squared plus 4 and our B is x squared minus 2. So we can substitute this into this. So our first bracket is going to be these two added together. So x squared plus 4 plus x squared minus 2. But then our second bracket is when B is subtracted from A. So x squared plus 4 take away x squared minus 2. Now just be ever so careful with the second bracket when we do the subtraction. We've got to minus the x squared, but we've also got to minus the minus 2. So that gives us a plus 2 there. So when we simplify these two brackets, we get this first one, we're going to get 2x squared plus 2. And then when we simplify this bracket here, our x squareds cancel, so we're left with 4 add 2, which is 6. So we've got 6 lots of 2x squared plus 2, which is 12x squared plus 12. It was fine if you chose to then factorize this and give your final answer as 12 lots of x squared plus 1. Up to you which of these two you gave as your final answer. Question 16. So we're given the ratio of red to blue is 3 to 17. But then we're told that the probability of purple is 0.2. So if the probability of purple is 0.2, then the probability of the red and the blue together must be 0.8. So these 20 counters represent a probability of 0.8. So if the probability of 20 counters is 0.8, the probability, when the probability is 0.2, this is a quarter of the chance, so it's got to be a quarter the number of counters. So that means the number of purple counters must be 5. Just go over that again. The ratio of the probabilities is, if you like, 4 to 1. So this has got to be a quarter the number of the reds and the blues combined. Quarter of 20 being 5. So in total we've got 25 counters, 3 add 17 and the 5. So the probability that Sam takes a red counter is 3 out of 25. If you want, you could have given it as a decimal 0.12. Question 17. So this is one of these questions where you're going to have to fully factorize the numerator and the denominator, and then the brackets will cancel, some of the brackets will cancel. So let's start off by factorizing the numerator. Now it may be that you do it by trial and inspection. I tend to do it this sort of more long-winded way. So I'm going to think of numbers, my magic pair of numbers which multiply make minus 9, being the 3 times the minus 3, but at the same time add to be the coefficient of x, which is the minus 8. So what numbers multiply to make minus 9 but add to be minus 8? Well, that's 1 and minus 9. So my next step is to break this second term here down into 2, so into a plus 1x and a minus 9x. It doesn't matter which way around, I've gone for the minus 9x first. So I've gone from 3 terms to 4 terms. I then fully factorise the first 2 terms, giving me 3x times x minus 3, and then fully factorise terms 3 and 4, giving me plus 1 lots of x minus 3. Then my final pair of brackets is the 2 components that aren't in a bracket at the moment, so the 3x plus 1, and my second bracket is the repeated bracket. So this is it once it's factorised. So my numerator is 3x plus 1 multiplied by x minus 3. Now if I then fully factorise the denominator, which is easier, just take out the 2x from each term, we get 2x multiplied by x minus 3, and you will see that these 2 brackets here cancel. There must be some cancelling, otherwise it wouldn't be simplified. So they cancel out, leaving me with 3x plus 1 over 2x. Question 18. Now, because this adjustment is outside the bracket, if you like, this is going to affect the y value and do it exactly as it says on the tin. So we're simply going to reduce all the y values by 2. So the curve is just going to shift down 2. So it's going to be a translation by 0 minus 2. So all the points are just shifting down 2. So rather than the y coordinate being 0, it's now minus 2. And take this minimum point, rather than minus 1, it's now minus 3. Rather than 0, it's minus 2. Rather than 1, it's minus 1. And rather than 0, it's 2. So the whole curve just shifts down 2. Question 19. So let's start off with the line which is perpendicular to PQ. So the 3x plus 2y equals 7. Now we want to rearrange this into y equals mx plus c format so we can see what its gradient is. So we want to make y the subject. So I've started off by taking away 3x from both sides. Done that over here. And then I've divided by 2, giving me y equals minus 3 over 2x plus 7 over 2. So the gradient of my perpendicular line is minus 3 over 2. Therefore, the gradient of PQ must be 2/3. You just basically flip this over and change the sign. Or putting it more poshly, if you like, minus 3 over 2 times 2 over 3 would give us minus 1. Anyway, our gradient of PQ is 2 over 3. So again, I've just done a little sketch here to help me gather my thoughts. So P is at 3, 4, and I've got Q up here where with my gradient as I go from P to Q being 2 over 3. My y step is 2 and my x step is 3. 2 over 3. I've just called it 2x and 3x because I don't want you thinking that this length is exactly 2 and this length is exactly 3. It isn't. It's just the ratio is 2 to 3. So what we can say is if we think about the length here, the length that is the same as this 2x, this length is, we're looking at the y coordinates here, we're going all the way from 4 up to b. So this length here is b minus 4, that equates to the 2x. And this length here, so looking at my x coordinates, is going all the way from 3 up to a, so that's a minus 3. So thinking of it as a ratio, the gradient is 2x over 3x, my 2 over 3, and the ratio with regard to the length is b minus 4 over a minus 3. So b minus 4 over a minus 3 equals a ratio of 2 to 3. So if we now just sort of multiply both sides by 3 and multiply both sides by a minus 3, we get 3 lots of b minus 4 equaling 2 lots of a minus 3. Multiply out the brackets, 3b minus 12 equals 2a minus 6. And I want to make b the subject. I've got to find an expression for b in terms of a. So let's go and add 12 to both sides. So we get 3b equals 2a plus 6. Divide through by 3, we get b equaling 2/3 a plus 2. And finally, question 20. So let's look at these two inequalities in turn. So let's start off by solving 3n plus 2 as less than or equal to 14. So take away 2 from both sides, divide by 3, we can see that n has got to be less than or equal to 4. Now it's also got to be another thing, n's also got to satisfy this equation here, this inequality here. So start off by multiplying through by n squared plus 5, so 6n is greater than n squared plus 5. Now I think it's easier to see it the other way around, so I've just rewritten it, effectively looking at it from right to left. So n squared plus 5 is less than 6n. So I've then taken away 6n from both sides to give me this quadratic inequality. Now I can factorize this. I need what magic numbers multiply to make 5, but add to equal minus 6, and that's minus 1 and minus 5. So this factorised is n minus 1, n minus 5. Now at this point, again, I think a sketch just helps us gather our thoughts. So the roots to this inequality are going to be at 1 and 5. It's a positive parabola, it's a smiley face graph, and we want all the values which are less than 0. So the values below the x-axis, so the values here. Now given that n is an integer, it is a whole number. Which numbers come in here? We've got 2, 3 and 4. So we need the values of n, remember, that satisfy both of these inequalities. So n has to be both less than or equal to 4, but also n has to be 2, 3 or 4. So 2, 3 and 4 also satisfy this inequality, so that our final answer is 2, 3 and 4.